Welcome to Elixir Wizards, a podcast brought to you by Smart Logic, a custom web and mobile application development shop based in Baltimore, Maryland. This season, season 3, we are talking about working with Elixir, and today we are talking specifically about functional programming with one of our favorite recurring guests, Brooklyn Zelenka. Brooklyn, how are you doing today?
I'm doing very well. How are you?
Doing lovely. Brooklyn, we're having a little bit of a different episode today. Why aren't we talking about Elixir?
So I used to do a lot of Elixir. I've written libraries. I used to do professionally. I used to teach Elixir as well. But my current company uses Haskel instead. So I've been primarily doing Haskel for about 2 years now.
And if listeners of the show remember, we've had you on now in the first and second season of Elixir Wizards, formerly known as Smart Software. And in both of those episodes, we talked a lot about Elixir and a lot about functional programming. And it came up that we could have a whole nother discussion really just on functional programming. And I think some other topics came up as potential topics of conversation. So we've got quite a lot to get through today. Eric, I'll let you just jump right into some of these functional programming questions.
Sure. So I guess what we can start with is, what does functional programming mean to you, since you're doing more than just Elixir?
So and this is a question that I get a lot, especially from people coming from the object-oriented world. What is FP? Why should I care about it? And to me, the two big reasons are I want code that I can reason about, which is to say, look at and know that what it does and that it's bug-free, and code that composes. So code that can reuse in many different places and not have to rewrite the same kind of thing over and over again.
So there's two things that you mentioned here. One is the code that you're reasoning about and code that you can reuse. I want to focus on the reasoning part because people say that a lot, but I think it might not be immediately clear upon hearing why functional programming is easier to reason about, like why it reduces cognitive load. Could you talk a little bit about that?
Sure, yeah. So functions really give you two things, right? They give you abstraction and application. So you can take a concept, abstract it away, give it a name, and then you can add arguments to it, including other functions, to make it more specific, the thing it's going to do. It means you have essentially unbounded abstraction. So you can start talking about very complex things in very compact, simple ways. So instead of having to write a loop every time, we can take that pattern and call it reduce, or even more specifically, a map. And now we know that when I run this thing, there's not a huge number of things that can happen. It's really just going to take whatever data structure I have and apply some function to every element in it. I'll get back the same order and the same structure if it's a tree, let's say. We can start working at things at a more semantic, more human level rather than just for the machine.
Mm-hmm. And maybe it would help to compare that to some other programming paradigms that are not as easy to reason about.
Yes. So it's possible to mix them, right? They're not fully in opposition. It's a little bit awkward to do object-oriented plus functional programming. It can be done, right? I guess the real distinction is imperative versus functional. In imperative programming, you're more concerned about how the machine is going to execute the exact instructions and kind of the sequence of events that are going to happen. So this is very mechanistic way of thinking, and you can get abstraction, especially with object orientation, where you can start giving names to things. But these names are really scoped. You're trying to hide information, encapsulation. So you're trying to hide as many details as possible rather than saying, this is the kind of data we're working on, and these are the transformations we're doing to them. We're instead saying, well, here's just some messages that we're passing around, and hopefully those do the right thing. In some ways, you can think of functional programming as being data-oriented as opposed to object-oriented.
And if somebody was totally naive, what is imperative programming?
Imperative programming is languages like, say, C is a really classic one, where you're saying, here's a sequence of instructions for the computer to execute, right? In a language that's as low level as C, it's, create a space in memory that I'm going to start putting things in.
Does that kind of just mean that there are like no rules in imperative programming? Like, is it just sort of delivering whatever instructions come to mind?
Yeah. So it depends on how much constraint is built into the language. But on the extreme, because this is all a spectrum, right? On the extreme, it's really, there are no rules. There's just instructions. You can mix and match them in any order. At the far end of this, when you start getting very low level, you can start saying, jump around in the program to this line in the program even, which makes it very hard to reason about what your program is going to do because you could jump from there to literally anywhere, even outside of your program and have a crash. So you get a lot of freedom because you can mix and match things and do very tricky things with it. But it's a total just sort of, here's your set of things you're allowed to do, go wild. Yeah. So it's less structured.
Right. And functional programming is more structured. It gives you more rules about how to organize your code.
Exactly. And it's not to say that you can't have a more structured imperative language like Rust, let's say, where they do a lot of things, especially with the type system, to add more structure and adding functions as well and naming things well so that you have a little bit more constraint. But that's the general, again, it's a continuum, right? Where you have from one side to the other.
So when you were first learning functional programming, what were some of the biggest hurdles that you were coming across? And maybe what was one of the early aha light bulb moments that you had?
Yeah, so I have a bit of a different background from most people in that I was doing functional programming from almost day one without getting to the whole background of why or how I ended up as a developer. But I had a bit of background with some mathematics from music theory primarily, and ended up at a shop that had a couple functional programmer advocates in it and was picking up, so started with JavaScript and started picking up things like Clojure and Haskel, within 6 months of starting to program. And I found it really sort of connected with the way that I tended to think about things. So I'm a bit of a strange case there. Not to say that I haven't worked in imperative languages, absolutely have, but I've always found functional programming to be a nice match for my brain. That said, because I've taught a lot of functional programming, Haskell, Clojure, Racket, etc., over the years. And I have noticed that there are some things that a lot of people get stuck on, and especially more experienced developers. So somebody has a really rock solid basis in Ruby, and they're a very senior Rubyist. They're trying to fit everything into how does the class work? Well, there isn't a class. You just have functions. Well, how's that even going to work, right? People coming straight out of, say, a coding bootcamp often have an easier time learning these things because they don't have to unlearn ways of thinking. So Elixir in particular, people would frequently get caught by, it kind of looks sort of like Ruby. Okay, great, but now I'm going to make this a class. No, that's not how this works. Okay, well then we'll use behaviors like classes. Not really how that works, right? So realizing that it is this inversion where the data is the important thing and you're piping it through a series of transformations rather than trying to always encapsulate and hide away a state, and that we don't have, just totally immutable objects, floating around. It's, you can do that, but you have to be explicit that that's what you're doing. Those really catch people. Even just some of the extra patterns that we get, or even some of the more power, sure, you can just spin that off into a task. It's well, then what do I do with the thread? You don't worry about it. It's just taken care of for you. So things like that I've found mostly get people tripped up, except for languages that, for example, have a type system when they're not used to doing a type system. And that's an entirely different conversation.
Which we will get to. I want to talk a little bit more about some of your experience with a variety of functional programming languages. You're working in Haskell now. You've used Elixir. Can you talk about the different functional programming languages that you've used, what you like about them, and why you might choose to use one of these languages over another?
Yeah. So I like programming languages sort of in general, and I play with them in my free time, plus have used a bunch in production. And functional programming is primarily a style, but there's some languages that are more tuned to it than others. So you can absolutely do functional programming in Python, right? Totally doable, becoming very common in JavaScript. But the languages that are really sort of aimed at it, obviously Haskell, which is the one that I'm working in these days, which is really aimed at making sure that the code does what it says it does and isn't going to have runtime errors, or as few as possible, so that the code will compile and then things ahead of time. Elixir and Erlang, which are, again, it's the language and then the ecosystem, right? So it has an ecosystem that's very aimed at concurrency and distributed systems, and especially Elixir at user friendliness, which you don't really see a lot in functional programming in general, right? To some degree, but especially Elixir, very focused on making things very friendly and nice. Elm, front-end language, becoming popular actually with Elixir people because it also has pipes, but it's a Haskell derivative. So it has a type system. It kind of looks like Haskell, but it also comes with an architecture similar to Redux, right? I'd say it's probably the opposite way around. Redux took it from Elm. I've worked in Clojure, which is a Lisp language, so lots of parentheses on the Java virtual machine.
Could I stop you at Clojure for a moment? Because we recently, and we're going to talk more about Chris later in the episode, but we recently had Chris Keithley on the show, and he talked about Clojure. I think his exact words, or it was something along the lines of Clojure is like the most perfectly designed language of all languages ever. Or at least, and I'm probably misrepresenting a little bit what he was saying, but I think it was very, very close to that. And I'm curious what your response or opinion of Clojure in light of that comment is.
Yeah, so I think Clojure is very nice. It definitely has trade-offs, especially being on the JVM. So the last time I used it was maybe like in a serious way. It was maybe 3-4 years ago. And it doesn't have some of the niceties you'd expect in some other functional languages, right? So you don't have, you have to make a distinction when you're going to be doing something iterative, right? For example, so you actually have to mark things in your code, whereas a lot of other functional languages can just look at the structure and say, oh, okay, I can optimize away this. This is just an inner loop, no big deal. But the tooling is quite nice. They've put a lot of effort into documentation. There's some very nice learning resources, and it's very flexible. So Lisps, Clojure included, are extensible in the same way that Elixir is, actually. And it has a lot of power just by virtue of being on the JVM. So you can use the entire Java ecosystem, which is enormous. So it's definitely a nice language. Oh, yeah. And then with some of the extensions too, people have written other languages on top of Clojure, or I guess DSLs on top of it as well. So it has a philosophy and a way of being very pragmatic of working. Most perfect language, I would have to listen to the podcast to really comment on that part. But I think every language comes with trade-offs, right? And every language has a place, right? You know, a lot of people like to hate on PHP, but it also makes a ton of money. So you know, it really depends on what your goals are.
Yeah, so does Java. If you could only use one programming language for the rest of your life and impose the same programming language on everybody else.
Oh, geez.
Like everybody else and you could only use one programming language for the rest of eternity, which one would you pick?
In that case, I would probably have to pick, probably it would be Racket. It's very extensible. You can write other languages in it.
Wait, say that again?
Racket.
Which one?
Racket.
Racket?
Racket.
This is totally out of left field. Why? Because it's extensible. I'm sorry. Go on.
Yeah, it's completely extensible. Somebody's written a language in it called Hackett, which is Haskell plus Racket. So you can do pretty much whatever you want. So, you know, and by extending the language, not by writing in, you know, a VM and an interpreter in it. So you can totally extend the language. You can do that in Elixir too, but it takes sometimes a little bit of hackery to make it work. And some of the libraries I've written have probably taken that. I'm not going to say that I've done that to the most extreme, but like definitely pretty far in that direction. So there are some limitations there that, say, Racket doesn't have.
I'm looking at Racket. I've never seen this before. It looks maybe like a Lisp.
Yeah.
Okay, it is. Okay.
It is a Lisp,
so
yeah.
I'm not a complete idiot.
Yeah.
That's cool. All right. I feel like you kind of dodged the question by just picking a language that you could then extend to kind of look like another language. But that's
Yes.
probably the smart way to handle that question, which was not a super great. Go ahead, Eric. You got something coming up here.
Yeah, as long as we all don't pick COBOL.
Yes.
All right. So I guess our next set of questions is: you currently do Haskell. Do you do other languages for your current job? And like, if you do have to switch back and forth, do you ever find there's like a weird context switch between functional and maybe say JavaScript that's not functional?
Yeah. So we write JavaScript, or I guess TypeScript, in a very functional way. So the style is similar enough. TypeScript has a slightly different type system with different trade-offs. So it's not, you know, exactly the same, but close enough. So there's less of a context switch than in the way that we're using it than could otherwise be. I used to find, you know, a few years ago, switching between languages, like I would, you know, spend the weekend with, I don't know, Erlang, and then go back to my Ruby job. And there would be this sort of like, oh, how do I think about things in this way again? You know, because the language you use does adjust the way you think about problems, right? I've gotten better at context switching between them, now, and kind of having, a better, just in my head being like, oh, I'm in this portion of the design space. So I can kind of, have these trade-offs, and that's gotten a lot easier. But yeah, so we do some TypeScript. We have some Elm as well, which is again, fairly Haskell-y. So we're definitely in that point in that general direction. When we brought on our first employee, the first week we said, do a comparison of TypeScript to Reason ML and see if it's, sort of ready for production for our uses, which it was close. It wasn't quite there at the time, but that turned out being a really nice intro to like really functional style JavaScript and then Haskell. So the short answer is, yeah, we don't really have as much of a context switch, but that's entirely because we're disciplined in the style we use.
Before I ask this next question, I think that as we wrap up the sort of languages discussion, I want to plug, we recently had on the show Bruce and Maggie Tate. Bruce is the author of 7 Languages in 7 Weeks, which you seem like you might have read.
I have read, yes. And 7 more languages, I think, as well. Yeah.
Oh, really?
Yes.
I don't know if he plugged that one in the episode or not. I recently actually just got he's also this guy behind Grox.io, and I got the passport that they do there. So I'm learning a little bit of Pony, which if you want to learn about Pony, go and listen to our episode with Bruce and Maggie. But speaking of podcast guests, we mentioned we had Chris Keithley on an episode, and we had a lot of discussions. So on this episode, which has done very well, he mentioned that he wrote a Haskell application, his first Haskell application. The first time he ran it, it seg-faulted, which I think is never supposed to happen with Haskell. So, like, why did this happen? Should he feel betrayed by the type system? Talk a little bit about that, and then I'll have a follow-up.
Would love to talk about that. So, mainly because we bumped into something similar a couple months ago. But so I'll sort of break it down into a few pieces. So, the type system itself
is a Haskell seg-fault like a mythical Pokemon?
Yeah, essentially. Yes. Yeah. So I think the main thing he's referencing there is most people's experience is if it compiles, it runs without errors, right? Which is sort of the point of having the type system. And you can weaken portions of the type system. If you need mutability, you can add it, all of that stuff. But for the most part, you should really just be in a nice safe subset, and everything should just work, right? The reason you get this, there's sort of 2 pieces. It's a pure language. So inside your application, everything is pure, even doing I/O. That's kind of handled at the edge of your application. And because of types. So when you have these 2, you have something called propositions as types, which means your types are literally logic propositions, right? So for the type system to be broken, reality would have to be broken. What ends up happening as you compile is the types get checked and then erased. And now you're left with an untyped program that then gets turned into C and then linked into libc. And this is where at least we ran into a problem. We could run things normally when we tried to create, and everything would work. We tried to create a fully static binary that used libc, and we were getting seg faults in a Haskell program, which really sucked. And so I started poking around, and people have been running into the same problem in Rust and Go and Elixir with BIFs and all kinds of things. So, and then sometimes people will update libc and things will work again, right? So the type system unfortunately doesn't solve your dependencies. And there are ways around that with alternates to libc like Moozle, but that's getting a little too deep. So in that case, my guess.
Let's get deep, because I feel like libc comes up a lot as like an issue for a myriad of different applications. Like people just have trouble with this particular dependency. What is it doing? What is Moozle as an alternative? Let's just dive into this, because I feel like it might help me in my job.
Yeah, absolutely. Okay. So when you're compiling something that's going through C, which is a lot of things, you tend to link in some existing libraries, and libc are those shared libraries, right? So GCC is the compiler, you link in these shared things. So even when you're building a static binary, the question is, which is to say something that all the code is included just right in the executable. The question is, how static is it? Because they assume everybody has libc kicking around. Is it the right libc? We don't know. So we were building, a static binary on one person's machine, but somebody with an older version of Linux couldn't use it because they had an older version of libc, which is not supposed to happen with a static binary. So there's this alternative thing called Moozle, and the workaround is you stick your build environment in a Docker file that uses that instead of libc, but it's not compatible with libc, so the entire system has to be Moozle instead of libc, and it's built specifically for doing embedded systems. So it doesn't assume that you have these libs kicking around. It just compiles everything down into a single binary, which is a pain that you have to do this workaround at all. And libc generally works, and GCC typically is good. But when you run into these sort of edge cases, it can be very frustrating.
I'm going to stick with Chris for a minute because he said something else that I think needs to be addressed. He made the assertion, and this is something from ElixirConf 2019. You can go listen to his talk. He made a very bold assertion that for most engineering problems, static typing is unnecessary and a hindrance to development velocity. We got him to double down on that opinion in our podcast with him, so I'm pretty confident I'm getting this one right. We, from our previous conversations, guessed that you would disagree with this. Can you give us the counterpoint? Why is static typing maybe not a hindrance to most engineering problems?
Yeah, so static typing really depends on which type of it. So I agree in the case of, say, Java static typing. Just frustrating, feels like it's getting in the way. When you have algebraic types, so something like what you have in Elixir or Rust, or sorry, not Elixir, Haskell, Rust, or Elm, that can be more helpful. Actually, Elixir does have a limited type system in Dialyzer, right? So you can put type specs in, and those can be helpful, and they help to define the interfaces for your functions. There's an entire, have an entire other conversation about just type systems if we really wanted to, right?
And I do want to just get clarification on one term. When you say algebraic types, like what does that mean in opposition to what?
Yes. So you can have just regular, sort of nominal types where you have, say, strings and integers, and that's kind of it, right? You have these very specific things that are available in your language. You might have a class that has an interface on it, and that's kind of the end. And it's very constraining. You can't really do a whole lot with that. And it's, I can't match int64 with int32. It's like, oh, okay, I've got to go and change the, coerce from one to the other. And it's just more of a pain than anything else. With algebraic types, you can create your own. So you can say, I have enums are one type. So, I have a street light, and it can be green, yellow, or red. I also have records. So I have a person, and they have a bunch of fields inside, name, age, address, let's say. And then you can compose them together. So a person has an address, and address is a type that lives elsewhere. So now I can have functions that work on address and that work on address inside of a person. And we can also do that switching logic, just like, street light is red, yellow, or green. We can say, this is an error or an okay case. And that's going to force us to handle both sides of that branch. So the way we do that case in Elixir is we, do a tuple with okay and error, and maybe other cases. What a type system does is says, when we're doing this case switching, we know how many cases there possibly can be. You're not missing any cases. You have to handle all of your edge cases. As a concrete example of that, a few years ago, we were calling out to an Erlang library. I'm trying to remember what exactly it did now, but the documentation said, here's the different cases that can come back as tuples. And they had different lengths of tuple and a bunch of different things. But there were some undocumented cases that would come back too. So we were having runtime errors in our code. So that wasn't great. So we created a catch-all, and then we would discover the extra errors over time. So it's workaroundable. People often say that having an untyped language is easier to iterate on because you're not having to, quote, fight with the type system. But it depends on how you use it. So yes, the type system will tell you, no, you can't do that, but it's preventing you from writing a bug. So you can also see it as having a conversation with the compiler or a conversation with the type checker, and being able to really, again, with this, being able to reason about and understand the code that you have in front of you, you can look at the type and say, oh, these are the cases I have to handle. This is the kind of thing I'm going to be dealing with. These are the only kinds of things it can do. It's only able to look at query users. It doesn't have unfettered access to the entire database, right? I know this is restricted to queries. So you get a lot of understanding about your program and a lot of reuse because you can also put some abstraction in your types as well and just have variables in there that have to line up. So is there value in untyped languages? I know that there's a couple attempts right now at adding a full type system to Elixir. And people often approach me about like, what do you think about this thing that's happening in this lab over here, right? Like, well, I think that's great. That's useful. I think there's absolutely space for untyped, or the other term is unityped languages. But I think it's mostly a matter of preference because it's a trade-off. Do you want to do more in tests, or do you want to have more of it in proofs?
Yeah, I sort of have a similar, having much less experience with static typing than you do, certainly, but my read on it at this point is that it comes down to a combination of requirements and style preferences. So like if stability is a requirement, static typing might be good. If velocity is more of the requirement, dynamic typing might be good. And I always think back to in Hackers and Painters, Paul Graham's book, where he talks a lot about dynamic typing and how valuable it is to be able to just sort of like slap paint against the canvas and not really worry or have any of these concerns. And it just seems sort of like a stylistic difference. Someone who's more deliberate would probably deliberate and discerning. Someone who's sort of seasoning ideas more might be more interested in like a static type language, while someone who's more just like going rogue, cowboy coding, like maybe like me, would enjoy dynamic typing. Obviously, there are requirements that need to play a role in that as well. Eric, do you have any follow-ups on the static typing question? I feel like we could probably talk about this all day.
Yeah, we probably could, but in the interest of time, maybe we should move on to our next topic. So the end of the last episode we recorded with you, I think in the chatter afterwards, you had mentioned that you had a lot of thoughts on macros. So yeah, we just wanted to kind of open up the space for whatever. Like, I guess we can start with, what is a macro?
Sure. Yeah. So the pithy definition is a macro is code that writes code, which I'm going to revise for the rest of what I'm about to say. It's a function that runs during the compiler pass that says, okay, so we've already broken up your code into some syntax tree, right? So the compiler has to break it down into a particular form that it understands. And it stops at one point and says, okay, are any of the functions in here macros, which means it's going to run now? And one of the things that a macro can take in is source code. So it can take a look at the tree and then modify it. Or one of the things it can do is modify this code tree. And so it's very nice for building DSLs, for writing test code, for anything that you don't want to have runtime costs on. So a really classic example is logging. Don't run, this detail of logging in production. So we're going to write a macro that eliminates all of the logging lines for, at the info level, let's say. And now it doesn't even have to do the decision at runtime. We've just created a program that doesn't have those instructions anymore. Or doing things with, say, I'm actually not certain that ecto schema syntax is a macro, but I believe it is, just from kind of the high-level syntax. And it's going to generate a whole bunch of other code and helpers and things that let you then, talk to the database, but you have this very nice high-level syntax. So that's what most people use macros for. I always like to say that there's 2 rules of Macro Club: never use macros and never use macros, because they're very difficult to debug. They're happening at compile time. How do you debug that? And this is, I guess, the first insight about macros is that they are compile time functions. They're not things that turn code into code. They're functions that run during the compiler pass. So you can write regular functions, test them on the data structure that is coming in for the AST, for the syntax tree, and then wrap it in essentially a shell of a macro and run it for real, right? And that it'll do the same sort of thing. So you can pull them out that way. The other thing you can do is add all kinds of interesting features to your programming language. So in type class, which is a library I wrote to bring in essentially a overloaded, more powerful version of protocols into Elixir from other languages like Scala, Rust, or Haskell, it checks at compile time that if there's inheritance, because now we have protocols, I can say I depend on these other protocols as well. If there's inheritance, check that this type is actually defined already on that protocol. We give it properties saying, if you have one for doing concatenation, it should follow the property that doing, regardless of the way you place the brackets around things, it'll always end up as the same, so you don't need brackets anywhere. So at compile time, we run all of the prop tests. So we have compile time guarantees. You could write a type system in macros. There's nothing stopping you from doing that. You can put messages in and print to the console how far you've gotten in the compiling steps. You can get more information about your program while it's compiling. And one of my absolute favorite uses of this is Credo, which uses macros to analyze code as well. So there's a lot you can do with macros beyond build a little DSL, right? And you can make them much more understandable and more testable by pulling them out into regular functions, running your tests on those with the right kind of type of thing, which is to say AST, which is a triple, a tuple with 3 fields.
I want to drill into this a little bit. We have a question here about sort of different levels or kinds of macros, and we have a word, a homoiconic, which I think Eric might know what that means, but I don't know what that means and how it is different from other iconics. So could you maybe tell me, could you enlighten me, please?
Yeah, sure. So homoiconic, that Elixir has this property, means that you can turn it into a Lisp. It also means that everything that you have in the main syntax of the program turns directly into AST, into syntax tree. So you can look at your program and say like, oh, okay, this is what the AST will look like roughly. There's nothing you can hide things in macros or in syntax, but it'll always turn into the same order and the same writing, right, as what's there. And when the macro is running, you don't do this in some other special syntax. You get regular Elixir to run it against. So the AST is Elixir, regular Elixir syntax. So if you have a function that can ingest tuples, you can work on the AST. So it's just saying that your high-level syntax is just a nice human representation of the AST.
So what would a non-homoiconic macro mean? Does it mean that it makes a language that is not the language that you wrote the macro in?
So you can't really write macros if it's not homoiconic.
What?
You can do quasi-quoting and things like that. But yeah, so it means that you can, so this is what Haskell has instead of macros. It means that you can write a string and then provide it a parser and a runner, which is a bunch of extra steps than just having Elixir written in Elixir, right?
I love how many words we have for things in computer science.
Yes.
I'm glad that we have smart people like you who know what they mean. We have a question here. Maybe you already answered it, but can you write macros that write macros?
I don't think I've ever tried. I don't think that you can. You can't invoke a macro in the module that it's been written. It has to get compiled first and then pulled into another place.
Is that an Elixir specific limitation or generally speaking, like as a rule of macros? I
mean, I don't want to speak for all languages. Usually when I've run into them, that's the case. Actually, you might be able to. You just wouldn't be able to use it right in line. I've never tried, is the short answer. But def macro is perfectly valid Elixir syntax. I don't see why you couldn't do it. You absolutely, almost certainly could. Whether or not that would be valuable, I'm not sure.
I would love it if one of our listeners would make an attempt at this and report back to us on Twitter about the outcome. And hopefully, it would be even better if you could find a useful reason to do it. Well, Eric, do you have any follow-up questions about the macros?
Yeah, I guess before we move on, so I've never used it, but I'm aware that C, or maybe it's just GCC or whatever, like they have, I think they're just preprocessor macros. Maybe I think it's what they're called, but I don't know if you know that maybe like what makes them different than say like a Lisp macro.
Yeah, so I mean they're using the term in a slightly different way. So I'm not a C expert by any stretch. They have a templating system where you can write essentially a shell outline. Right, shell is not like bash shell, but sort of a file with holes in it that you can then fill stuff into, almost like a half-done source file that you can then plug things into, which is not really a macro in the Lisp sense. Haskell has template Haskell and this whole quasi-quoting idea. It's a little bit different from being able to extend your language with the language itself, right? So it almost has this almost recursive nature to the language, where you have, if you're willing to put in enough effort, you can do almost anything. Elixir has hygienic macros, which means that it can't affect things outside of the block that it's in. There are some tricks to get around some of those cases, but they're really like specific to the sorts of thing you're trying to do. And I would discourage people unless you really have a reason to do that. But yeah, it's a different kind of thing than a preprocessor in C.
Very well. Brooklyn, we like to leave you with the final word. So do you have any plugs, asks for the audience, anything like that you want to shamelessly self-promote? Now is the time.
A shameless self-promotion, sure. So I work at a company called Fission, where we're trying to make web development tools that make web dev easier, that make it so that you don't need DevOps, and to make teams more productive, and to give more power to users by letting them own their own data. So if anybody's interested in things like that, you can check us out at fission.codes.
Super duper. And I guess I'll just tack this on, since last time you told us, hey, we should talk about macros. Is there anything that we need to talk about in season 4? Call your shot now.
Things to talk about in season 4 with me, if I were to come back, or just in general?
Well, either way.
Either way.
Specifically about you, for sure, because, we're going to have you back on, Lord willing. But also, if you have an idea about generally speaking, we'd love to hear that too.
I would love to hear people talk more about application architecture in Elixir, which I think is a lot of people just kind of use, say, Phoenix, and they're just going to follow that. But what if you're not in Phoenix? Or what about the part of your application that isn't the web?
Eric has done some innovating there, at least in our organization. And we tried to get it included, like, how there's a web folder and it's usually labeled like application name _web. We really were trying to lobby to get that just shortened to web. They didn't want to do it. I don't think they would have accepted the patch anyway. So, because they just didn't seem like to think it was worth it. But he's done some other things too. I don't know. It's all domain driven architecture, right? Like that's what you call Phoenix architecture. That's really helpful. And what about you? When you come on, do you want to talk about architecture, or do you have something that's been obsessing you that you would want to talk about in season 4?
So I've been thinking a lot about architecture lately. I just gave a keynote in Amsterdam on the 3-layer architecture and porting that into Elixir, and essentially how people can add a protocol, quote, object-oriented layer a little bit more in Elixir to get more power and ability there. Something that I'm going to mention just almost as a teaser, and I'm not entirely certain that this project is going to go forward, but it might be interesting to talk about if it does, is, as I mentioned, I'm working in Haskel. Haskell is a fantastic language. It's lovely, but it's 30 years old, and you can feel that it has some opinions that have had to evolve over time. In a lot of ways, it feels like how Erlang and Elixir are related. I would love to see an Elixir for Haskel, or an Elixir-like approach. It might not look like Elixir, different trade-offs. So something I've been playing around with is maybe kicking off a project like that, taking a lot of the learnings we have from projects like this and creating a new language.
I think you could get a lot of energy behind that if you get it going. Haskell is definitely not the most user-friendly language, so something Elixir-y might be nice. Eric, do you have anything before I close this out here?
I just look forward to seeing and wherever that goes.
Brooklyn, Zelenka, thank you so much for joining us today.
Thank you for having me. It's always a pleasure.
That's it for this episode of Elixir Wizards. Thank you again to our guest, Brooklyn Zelenka, and my co-host, Eric Ostrich. Once again, I am Justice Epen. Elixir Wizards is a Smart Logic podcast. Here at Smart Logic, we are always looking to take on new projects, building web apps in Elixir, Rails, and React. Infrastructure projects using Kubernetes, mobile apps using React Native. We'd love to hear from you if you have a project we could help you with. Don't forget to hit that like button or that subscribe button wherever you are listening. You can also find us on Instagram and Twitter and Facebook. So add us on all of those. Reach out. Let us know how we're doing. Let us know how we could do better. And join us again next week for Elixir Wizards.